Hello and welcome to Learn Python 3 the Hard Way, exercise 44. In this exercise, we get deeper into the difference, or not the difference, but sort of like what makes something inheritance and what makes something composition. So remember, when you go through this exercise, it's sort of a continuation of the last exercise where you're learning about things that have a or is something else. But you're doing it in a much more Pythonic way, Python way, where you're basically learning how things are picked up and where things are. So I'm going to switch over to the code real quick. Okay, so in this example, what we're doing is, what I'm showing you is one of the things that makes object-oriented programming attractive is the implicit way that things are added to children or to child classes. So what you're trying to do when you design a class like this is you're trying to create a system where a lot of the features and functions automatically show up. So that way you only have to implement them in one place or one time. So if I had a whole bunch of very similar things, a bunch of cars, a bunch of user types, things like that, what I would do is I would take common things about all the cars and I would put them in a base class called car. And then I would subclass for anything that was different about individual cars. So that's what a lot of object-oriented programming is trying to give you. A way for you to extend and to include basic things. Okay, so we've got this idea that we can include basic things implicitly. That, though, makes it difficult to find where things come from. So that's why you have to sort of learn that if you inherit from parent, right, and parent doesn't seem to, let me get back to this, and child does something like this implicit call, and you don't see it in here, it's in parent. Now where it gets dangerous is what if parent inherits from something? So if parent inherits from grandparent, and you don't see a feature in parent, that means you have to go find it in grandparent. So that's the significance of understanding inheritance chains, and that you pick up implicitly, meaning you don't have to explicitly say they should do it. Now, in the next one, we're talking about how we can override these implicit things. So the default for this is to have implicit children or implicit functions from the parent will get picked up by the child. Okay? It's implied that the child will get the parent's features. Okay, so if that's the case, then how do you change it? How do you change what the parent does? Well, how you do it is you just define a new thing with the same name, and then by default, that is now overriding it. So let me run these two examples. If I do Python ex44a, we see that parent implicit is called both times, even though the child class doesn't have anything called. When I call it here, it shows up here. Okay? So now the next part is if I run this next script, 44b, the parent override ran, this one ran, but when I called it in child, the child override function ran. So that's how you circumvent the implicit that you get from child and parent objects. Okay, so now we have two ways. We can take all of our base stuff and we can put it into that, and then in the few places where we have to change it, we can just override it by defining the same function with the same name. Okay, so what happens if what you want to do is you want to alter the parent? You still want the parent to run, but you want to change how it runs. Well, you have to be able to do something called super. You have to be able to, from within child, ask, who is my parent, and tell them to do this. Okay? So one good example of this is when you want to wrap. I want to wrap a function in parent with some extra stuff. So what I have to do is I have to do some code before and some code after. So the trick is you do super. Super is a function that takes the current class you're working with and self, and then returns the parent class. Now, you do this because maybe the parent class is a little tricky. Like you could, maybe do something where you just found parent on your own and did this. But with the super function, it does it right. You're going to get it wrong if you try to do it manually. It will get it right. And then you can do code after. If all you want to do is call the super function, then do it. And if you don't want the parent's version of this to run, then just override it. Okay, so if we do this, let's do C. We see parent altered, right? So there's parent altered. That's when we just did parent down here. And parent here is called only after the child before and the child after gets called. Oh, let me rephrase that. The child before gets called, then the parent altered gets called, then the parent after gets called. Okay, this also can work if you need to call a few functions of the parent class before you do this. All right, so that's sort of the patterns. You do it where you implicitly just use the parent's features. You do it where you override it, and you do it where you wrap around it. And also, that explains why self has to exist. Some languages don't explicitly give you a self as like an extra parameter. In those languages, they have advantages and disadvantages. There's no reason why one is better than another. But what happens is, when you get a self object, the reason you do that is because in parent, I really don't know what I'm getting. So in this case, implicit here, right? Actually, we can do this real quick. Let me just do this. Let's do that. Okay, and rerun A. So see, self in parent implicit is a parent object, but self here, this is the second one, is a child object. If you didn't have this self object that's being passed to you to work on, you would have to ask every time you went in, you'd have to ask, is this a child, is it a parent? The parent classes would all have to know what their implementations are, and that would break. It's better to just be generic. Just say, look, as long as I get a self and I can do stuff to it, then I'm good. So that's why that exists. That's why this lets you do overriding here. It's why it lets you wrap it and then pass self onto it. It's just an easier way to deal with how do parent classes work on objects that should be like them without knowing what the child is. Okay, so now let's look at the next script. Maybe, because Adam is being very slow today. So now we're doing all three. So notice there is no implicit function because it's implied. I am implying that I'm going to get it. I define all these things and I imply it. Override, when we call the child, should replace the parents, and then altered should run just like the altered did. So let's run that. And there we go. The parent implicit runs twice, the child override, and then so on and so forth. So it works as expected. And we're calling it in different orders. See that? So study that. In fact, this would be a very good place to do a lot. This exercise, or this code right here, 44D, would be a great place to do a lot of debug printing, where you do parent.implicit, and then you do self. And do that, and a lot of exiting. Just like that. Do a lot of that because it'll tell you where these are getting. So see how this is parent implicit enters with a child? It will tell you what is the type of object that that function is getting, and it will help you figure out where things are. Now, the significance of this is when you have a bug, let's say you're down here and someone calls son implicit right there. So that's going to come up. You're going to go, oh, okay, I'm going to look in the child class, and you don't have an implicit. Now you have to figure out where that's coming from. Figuring out where things live, where they're assigned, where they're created, where they're written is a big part of finding bugs, because if you don't know where stuff's coming from, you can't find out why it's failing. So when you run into that situation, you have to then go through all of the code and find out where this is. And trust me, one of the cornerstones of object-oriented programming, and it's not a good cornerstone, is people having convoluted locations and calling chains to find something, where it's not just in the parent, it's in the parent and the parent's calling this, which calls that, which calls this, which is inherited from that, which is inherited from that. And 9 functions later, you finally find the actual place where the bug is located. Okay, so now let's look at the sort of other way to do this. Okay, this is using has-a. This is how you do it with composition. And the reason why I show you this is in some cases, in a lot of cases, you cannot inherit from a class. You have to sort of wrap it with a better API or a smaller API. API means Application Programmer Interface. So that's all these functions that I use to interface with something. So a very common pattern is I have a class from some other place, a company gave it to me, something in a different language, whatever. I cannot access it directly. It's a C++ class and I'm using Python, so there's not much of a way I can interact with it. What I would do instead, or most likely it's a vendor, right? I would create what's called a wrapper, and I would use composition. And composition is the idea that all of the interaction is done with I have a thing and I tell it to do stuff. And if you look, it's not much different from the other code. The only difference is I create my other and then I just call the functions on it like that. I don't have to worry about the same, like, is it implied where that thing is? Is it implicit in this way? I don't have to worry about where it comes from. I know exactly where it comes from. It's much more explicit this way. Now, I prefer to have the majority. I almost tell people most of the time, the way you design your software is using composition, unless you can find a reason why inheritance is better, right? And that seems to solve a lot of problems with object-oriented design in Python. There's some languages, I would say Java, where for style and also because of the way it works, it's usually better that you do inheritance. But with Python, you can actually use composition, and a lot of other languages too. Okay, so we have this composition version. Let's see how it runs. And this is similar. I'm going to run 44E now. And you see it's similar to the other one. It runs the other implicit, and then it does the child override, and so on and so forth. So we just do son implicit is running other implicit. There you go. And it's not implicit anymore. Now it's very explicit. I'm just using the same name from the previous class. So we have exercise 44E. That's the last one. When you read the book, what I recommend, when you go back through the book and you're studying, what I recommend, right, is go through and enter all this code in and do the debug printing of every self object going through every function to find out how this flows, okay? Then what I would do next is I would roll back to the previous exercise and come up with your own object-oriented problem, something you need to model. We call this modeling, where you're given sort of a description of, I've got a boat and it has to go to the pier, and the pier has to catch boats and it has to track them. You just write up something from your daily life, something you do all the time, and try to craft 2 versions of that. Keep it small, but try to craft 2 versions, one that uses object-oriented inheritance and one that uses composition to provide the same model. Keep it small and interact with it. The other thing I would do is find out how many ways you can break this. And now we're getting into debugging stuff. Object-oriented stuff. So debugging and finding out where things are is very difficult. So learning to break things is very, very important here. For example, I'm in the E one. Let me do this. For example, a very common bug is to do things like this. And then when you run it, you get this implicit takes 0 positional arguments, but 1 was given. And you go and you look, you're like, what? No, it doesn't take it doesn't take one. Where's that one coming from? All the time people do that. So that's what the self comes in. Another one, if you really want to get advanced, if you really want to mess around with this, you can put multiple classes in here. So you could do parent, you could do toaster, and frog, and create 3 classes that have 3 different things, and they'll all get included in here. And then it gets super weird. I tell people to not use that. I've written a lot of object-oriented code, and I think the only time I've used that is when someone made something I had to use, and I had to do that. It's never been that useful. In almost every instance, I've basically never done that. Okay. Find multiple ways to break this. Find ways to print out what's going on, who is calling what. Study the chains of calling and also inheritance and how inheritance works. And then I suggest you sit down and craft up your own description, your own object-oriented analysis, and your inheritance, and try one version with inheritance and one version with composition. And I think that will really teach you this exercise. Okay, see you at the next one.